our purpose is ultimately HRV, okay? And HRV means what?
Heart rate variability.
So what is your understanding?
How much the heart rate changes from something to another.
From the base to
In what time frame?
A few seconds.
like 5 minutes or 3 minutes.
So
Please bring chair.
you were saying
Have a seat. Some stools and seat.
ايه قاعد يشرح عن الهارت ريت فاريبيليتي فقاعد يقول انتم ايش فهمكم what do you understand about it.
okay.
This is important. DT. Okay. So, all right. I think it will be easy to understand. This is a deep respiration. Okay. Here also there is deep respiration. So what I am going to do is I am going to highlight this area just to make it zoom view. All right. And then we have the option. We have marker here. We can bring a marker and put it at one QRS, R wave rather. And if we put it the cursor onto the next one, we get the
Can you turn up the brightness?
brightness. How you are going to turn up the brightness? I am an old person, so I have to find out the things. So it's better. All right. If you now bring the cursor to the next, so here you get the timing between two successive R waves.
So the time between two peaks.
Two peaks. It's 0.752.
How did we do this? What did we choose from the settings above?
We have not chosen anything. We have just zoomed this thing and brought a marker here to one R wave and put the cursor onto the second. Okay, just to see the timing. This is not a thing which you will be using later. It is just to demonstrate. Okay. So it is something around 765 millisecond. If we go to the next one or the previous one, it is 753 milli. So there's a difference, isn't it?
Yes.
Between the two. So every beat is different.
Yes.
This is variability.
Every 2 beats have a different time.
Different time interval. So there is a beat to beat variation. This is what we call as instantaneous heart rate, and we will derive the heart rate like 60 over whatever is the time interval, say 0.76. So heart rate is something around, we can actually calculate probably 75. And here it may be 78. Next it may be 80.
60 over what?
60 over 0.76. So exactly what it is. And this is now the time.
78, yeah.
78. It was 78. And now the time interval is 0.994. 60 over 0.994.
60.
Okay. So how much is the difference between here it is 76 and at another place it is 60 beats per minute. This is the instantaneous heart rate.
At the moment.
Yeah, at that particular instant. So why it is changing? If you can recall your physiology, there is an intrinsic heart rate. Intrinsic heart rate means if all innervation is gone,
Yes.
what will be the heart rate?
The rate of the sinus.
Sinus? No,
Yes.
that is approximately 100. So it is being slowed down by parasympathetic system, and it is being accelerated by sympathetic system. So there is a balance between the two. So if everything is normal, you will have quite large variations, something in the range of say 30 beats. So during deep inspiration, the heart rate goes fast. During expiration, it goes slow. And this variation could be quite enormous. This is what we are after. We want to see how much are the variations in response to various maneuvers also, but first spontaneously. If we are just breathing normally, even then there are variations. But
Which is the instantaneous.
yes, instantaneous. But with maneuvers, it can be exaggerated and exaggerated quite a lot. So there are certain normal limits for that. So it should be at least this much. So cardiovascular autonomic reactivity tests are for that. How much you
The
can
change.
go up with challenge. A person with neuropathy may not have that reserve. His heart rate may not change. During normal respiration, his heart rate variation is say 2-3 beats only between inspiration and expiration. During deep breathing, it remains the same. It means he has got
It's autonomic dysfunction.
neuropathy, autonomic dysfunction. Okay, and there are so many parameters that are derived from just this RR interval, and you have to be very, very clear in your mind. The most critical point in HRV calculations would be that you pick all the peaks properly.
All the peaks are detected.
All the peaks are there. Because if you miss one peak, the distance between two R waves will be double. All calculations will be wrong. Get my point?
Yes.
So that's why it is very important that you get a clean ECG record. We did not pay proper attention up till now. From next time onwards, you try to prepare the skin properly and put the gel and everything and try to get a cleaner record.
So what do you think about this record? This one? Is it?
Yes, we will be able to get the HRV. Now I'll tell you how to do that, and then you will have to make a preparation also. So this was the first thing to understand, that you have got a beat-to-beat variation, and this is our purpose. Now,
whose notebook is this? Is this ours or yours؟ طبعا مين اللي خط اوضح شباب عشان ياخذ نوتات بس عشان نتذكرهم من هذا الانستانس
خطي
حتى اكتب معرفة تقدر تاخذ نوتات بس تسجل عليها بس الاشياء اللي احنا بنسويها اناليسيس انه هذا الانستانس
so we'll go back to normal recording.
ويبغاك انت تكتب.
عشان احط بعد واضح عندك ولا
So in making HRV,
صح هو قاعد يصور الحين خلاص.
in making HRV, you will have to select a region which is most clear, without any artifacts, without any things where the signal becomes disturbed for any reason. So I think this whole region is reasonably good. The standard thing is to have a 5-minute step for ECG in order to have proper HRV calculations.
Doctor, that reminds me, please. After the hand grip, is there a time for rest? Rest time after
Yes,
hand grip?
always. Whenever you do a maneuver, you give it a rest so that the person goes back to normal.
So how much time? 3 minutes, right?
What's the minimum rest, doctor?
2 to 3 minutes is reasonable. It depends upon the maneuver, what sort of maneuver you are doing.
We
But-
have a 5 minutes after the head-up tilt. Can we exclude it at the end?
At the end, after everything, we have a 5 minutes wait after we put the
Yes.
patient down. So can we exclude it? Exclude
No, you cannot exclude, because we make a comparison during tilt and post tilt. So pre-tilt 5 minutes, tilt 5 minutes, and post tilt 5 minutes, because we make a comparison pre and post also.
Even the pre-5 minutes are on board.
Yes. So you have to be clear in that protocol.
We are aiming to reduce the time as much as possible, because
The whole
what we found that it is exhausting
from the participant
for the
himself.
participant.
So I can reassure you, we have at least gone through 100 participants through this procedure. Okay, they have been able to do it. So don't worry about it. You will have to reassure the participants, yes. But you cannot make a shortcut. These are standard procedures, and if you are reporting it to a journal, you will have to say with authority that we have done this protocol. Okay? Otherwise, your data is invalid. You should be very clear in your mind.
So
No
everything is
shortcuts.
necessary.
Hmm?
Everything is necessary.
Yes. Okay. Now for HRV, we have got this software already installed. Okay. We have got certain settings. Number one. Okay. Setting number one is you have to select the channel, which is the ECG channel, or we could even do HRV on this phenometer data. Okay. In case the ECG has gone or so we have a backup. So channel 1 is okay. We could change the channel, say phenometer. It is possible, but we are not doing. Now we will do only a selection, not the whole channel. We want only the okay. This is step number 2. It is human ECG. Okay, we are not. These are things that are already default settings. So we don't change many of those things. Everything is just set. I'll tell you later on that in certain cases we will have to change certain small things. But that we will come to. Okay. So when we give okay, see all the peaks are identified. So this is the program itself is identifying all the peaks. But some of them are blue, some of them are gray, and some are.
Yes. What setting did we choose before to decide that it's selective and we just want this portion?
So we have already made this selection.
We chose the portion we want.
Yes.
And then what do we do?
We go to
Yes, and
setting.
the heart rate variable,
Yes.
and then selective, and that's it. Okay,
Yeah,
make sure
okay.
it's human, and that's it. Yeah.
So, all right. Now these indicate that some of the peaks they are not according to the settings which were there in the setting side, and we have got an option here where we can
Exclude them.
classify the
Yeah.
beats. So we'll include them actually
Oh.
because all of them seem to be normal. So now this is a box that the program in a default setting is just including these beats. So what we are going to do is we are going to extend this box up till here. Okay. So all of them they become blue. Now what you have to see that this is the time interval between successive beats or whatever in milliseconds. So at a heart rate of say 70 beats per minute, your beat to beat interval will be something around 800 milliseconds at least. Okay, and it will not be more than say 1300 milliseconds or 1400 milliseconds. So now we have got a span where 600 to about 1500. So all this seems to be very logical. If there was a beat which was going there at 2000 milliseconds, so that should immediately make us think that this is an abnormal thing.
Yeah, significant change. Yeah.
So if that happens, we probably missed one peak.
Yes. So we have this option. We do not select that peak. So a program will automatically exclude that from the
That would be
calculations.
considered like an artifact? Or?
Yes, it will be an artifact, ectopic. Okay. So now we are satisfied. We go back and see the record. All of them are blue. Okay. Next thing is we generate a report. It has already analyzed. That's why it is. But we can just press analyze. So analysis is complete, and these are the reports. Okay. This is the report view, and these are in chart view. So we take the report. This is our aim. Now I'll just quickly tell you the things. So you will have start of the analysis defined. at time interval 7 minutes 24 seconds. Analysis ends, whatever it was. It should be total included beats. If we are having a 5-minute interval, so most likely you will have around 300 beats. 5, 6 or 30, isn't it? So if you have normal heart rate. Included normal beats 98, included ectopic beats 0. So we have a command there. We would say that we don't want to include ectopic beats, so exclude ectopic beats. Average RR. So this is for 98 beats, the average was 770, median 760. Then the next thing is standard deviation of RR interval. How much the beats are varying from each other. So over this whole time period, there is a standard deviation calculated. You are familiar with this much statistics of standard deviation. Then we are not really concerned about standard deviation because these are different intervals. Next one is coefficient of variation. This is again statistical calculation where standard deviation and mean, both of them are included in calculation. So we'll keep this one also. Now average heart rate is 78 beats per minute, and SD rate and ST again we are not using these two data up till now. So probably in this project we will use this data. Then is RMSSD, again statistical term, which is root of mean of what we can say, mean of square of differences between two successive RR intervals. So it's a long terminology, but the thing is
What is it?
root of mean of square of successive RR intervals. So again statistical term, similar to standard deviation. Okay.
Are we concerned with it?
Yes, this is the one of the most important ones. Then this PRR50 means that percentage of RR intervals that are having at least interval of 50 millisecond more as compared to their previous or subsequent beat. So we have R wave, this is another R wave, this is another R wave, this is another R wave. This one is 900, this one is 955. This one is say 1020. So the difference between these two is more than 50 millisecond, and difference between these is also more than 50 millisecond. This one is also 900, this one is also 920. So here the difference is less than that. Okay, so we have got say 5. Out of these 5, there are 2 intervals which are more than 50 millisecond as compared to their previous one, immediately previous one. Okay, so the percentage would be out of
All of them.
total there are 5, so 2 of them there, so 40%. Okay, so this will be automated. So here we have about 13% of the total beats which are showing a difference of more than 50 millisecond from the previous one. Okay, so we are all these calculations, they are under the main heading of time domain parameters. Time domain. And these ones basically indicate how much is the activity of parasympathetic system. The larger the RMSSD, the larger the standard deviations, the greater the PRR50, it means there is a lot of variation going on. This is a good thing. And if PRR50 is 0, RMSSD is 10, 15 only, SDRR is only 10, 15, it means there are no variations going on. It is an indication that parasympathetic activity is very weak.
What does it mean?
Parasympathetic control is very weak.
When there is no change.
Yes, very. So there are no variations. If you are exercising, your heart rate is very high, and there the parasympathetic is almost gone. Only sympathetic is active. So you don't see much variations here. But that is a normal exercise thing. If in a resting condition nothing happens, it means neuropathy, autonomic neuropathy. Very frequently seen in diabetes. There is another type of calculation which is called frequency domain. There is a system that they calculate how many peaks are there, how many, which frequency is high, which frequency is low. They say that it is Fourier transformation. So that's mathematical. I am not good in that. But again, it will give us a good idea about activity of sympathetic and parasympathetic system. And we are concerned with LF, low frequency, and high frequency, HF. HF is basically similar to what RMSSD is doing, that is parasympathetic activity indicator, whereas LF is more inclined towards sympathetic. Okay. And then there is a ratio of LF to HF. LF is sympathetic, HF is parasympathetic, so it's a sympatho-vagal balance. Sympatho? Balance between the two systems. All right. Similarly, SD1, further another type of calculation is there. Standard deviation 1, standard deviation 2. SD1 is again similar to RMSSD and this high frequency. So all these are giving us different aspects of parasympathetic activity. So we'll have to register all these things. Okay. So one thing is that you get the report, type. But there is a simpler solution also. Now I'll go to that. Now, when we have, yes, just let us just see one chart also. This is for ST1 and ST2. Just switch off these things. This is called a point care plot. From this, the program is calculating ST1 and ST2. And what it is, this one is calculating, plotting basically every R wave with respect to the previous one. See, this one is about 640. These are milliseconds. And these are also milliseconds. So what is written RR interval? Say this is the RR interval. My name is at RR interval number 2. Okay. The next RR interval is RR interval number 3. It is 955 milliseconds. So the plot is between these 2 points. So if I plot here, 900, 900, 1000. So this is 950. So my plot is, this point is this one. The next one is 955. Now it will be here. And further is 1020. So that will be here. So it's written next RR interval. So we are plotting every RR interval with the next one. Next one is. So this all is the whole of this scatter of the data. This again is telling you the variability immediately on a graph. That is, we have got quite a scattered thing. Good. But scattering up till a certain limit is good. Beyond those limits, again there will be a disease process. Okay. So this small one ultimately is calculated at ST1 and the large one is as ST2. So this is just a brief introduction so that you know how to judge the data, and beat classifier view is our one important thing. Say if I change this one, no, first of all just see what were the values. Say for RMSSD 32, SDRR is 75. Okay. Now if we exclude certain beats and make our calculation on a smaller scale. See the report now. RMSSG become 28. From 32, it is 28. And from 75, it comes to 43.
What was the first one, the change? What was it? What factor?
We have just reduced the number of beats included in the calculation.
Yes, but the one that changed from 32 to 28,
RMSST.
which is, remind me.
This one. Root of mean of square of successive RR intervals.
And the other is the standard deviation.
Yes. Okay. So this I have just to show you that if you do not include a large portion for calculation, your calculations are not valid.
So that's why we need the full 5 minutes.
Yes, this is the standard thing you will have to report. We can try smaller ones at places where we have got some disturbance in ECG and we cannot get a 5 minute.
Yeah, so we can get like 4 minutes.
Yes.
around it.
Okay. But keep in mind that yes, we should have 5 minutes. Should have 5 minutes. Okay. Now, next thing would be that we can develop a file. Say, for example, all this data. Sorry, I will just first increase this so that this is a data pad. Data pad, and we have a command add to data pad. So whatever calculations are there, they can be added and they can be seen here. At this point we have not configured this file, so it is only giving us a few things. Say for example, average rate of pulse and respiration and venometer. These are not the things which we require. We will now configure it step by step. Number one, see we have got an option. Right, start again. Open up the data pad. Step one, go to data pad. Then this is channel number one. Column number one, not channel one, column one. So we go to.
But it is channel 1, the channel that we chose for the
Yes,
ECG. Yeah.
but we don't want these things. Now we have to configure a file where we want HRV calculations to be automatically put into this file. We don't have to type. This is our purpose now. So for that we need many items. Number one is which is the section which we are recording. So we will start with selection start. Okay.
Selection in what? What's written there? I can't see it.
The selection which we have done there. This portion.
Yeah, I know, but what's the options name?
Selection and active point. So we say selection start. Okay. Now it is giving us some sort of a timing. Second, we also go to selection end. We can go to total duration of the selection. Say it is 76 seconds. Okay. Then we can go to comments also, because you will be giving some comments. This is the beginning of deep breathing, this is the end of deep breathing. So you should know what is there. So comment time, no problem. Full comment text can be there. Okay. Then from here onwards we can have actual HRV parameters. So we press HRV and now there are so many things there. Yes, it itself is giving the analysis start. So we'll give this one as number one. And start of the analysis. We might delete the ones which we have done in the beginning. This selection start. Analysis start. Then go to HRV again.
And
Analysis end. Okay. Then we go to HRV again,
The whole thing.
total beats.
Yes.
Okay, and this is how you will have, say, how many channels? Let us see.
So
1, 2.
where do we decide that it's 5 minutes? When we pointed to them before?
Hmm?
Where do we put on the chart that we want the portion of analysis for the 5 minutes we've chosen? When
You
decide-
select
Yeah,
initially.
when we
yourself.
selected it before.
Yes. Okay. So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Up till RR. X is 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 parameters. Just create this file.
We need all of the 27
Yeah.
parameters.
Yes. Because this is one time job. Next, what you have to do, just press add data and all the values will be added here. Because later on we might start thinking, oh, why I missed this one. Then you have to redo the whole thing.
Yeah. Okay, so it's gonna be our database.
Yes.
This Excel chart.
This will be your template file.
Yeah.
So whatever you record, you will open this file and append the newly recorded file to the this file and name it. So automatically then you just select add data, select add data, select add data. So all the things will be there. It makes your life very easy. Your job will be to select the correct area for data analysis and do some sort of settings if required. Okay?
What are the areas that are required?
Yes. Very simple. You are doing a baseline and then you are doing various maneuvers. So all those things are to be done.
So 5 minutes, 5 minutes.
Yes.
For the base and for the...
Say for example, you will prepare this file yourself now. I will say okay. These are some of the parameters.
Does it show the data we collected or what? Does it show it now?
It will show. Let me just say HRV average RR. Okay. I will select 2 or 3 things so that we have go to HRV and go to SDRR. This is very important. We will be doing all the time. And we go to RMSST. Okay. Just for demonstration. So we go back here. And now we say add data. Go back. So this is added. Okay. Comment also coming D, P, deep breathing. It should have been B, not P. Okay. Now you go to the next area probably. So this is again normal breathing. Analyze. So all blue, but there is something here missing. Let us see in beat classifier view what has happened. This is the beat that is missing. We include this one also.
Isn't this an artifact?
This is no, this is not. So see, it is.
It's not above the top 15.
About 1 second.
Yeah.
It is not 2 seconds. So it is within the normal range. So now we go back here and see all of them. So you see that blue dots, they are coming closer and going apart. This is the variation. This is the variation. Add to data pad. Okay. Now see. 770, 769, almost same because this is all is in deep breathing. Now we go outside deep breathing. Say this area. Analyze. Okay.
So good, so just add.
Just add. See. Immediately RMSSD has gone to 15 and the SDRR 35. So in deep breathing the variation is much more exaggerated. Okay. So the demonstration is very clear. Okay, sir?
Yes.
So we are just looking at these two things. Average RR was 770, 769, and here the average RR is 721. The other important thing, now if you see, the total beats are only 48. So I have not selected a large area, equivalent to what was selected before. So this is my mistake. I should use an equivalent area to make a comparison.
So the second area was less than 5 minutes. So.
No, I have not. Deep breathing was only for 1 minute. Okay. So we cannot have 5 minutes there.
Right.
But this is just for demonstration that this is what you are going to do. Now this is a disturbed area. Let us include this one and see what happens. Analyze. The program is picking up the things correctly here, okay? But there is a R wave is very small. It has been missed. That's why there is no blue spot. Can you see that? I will just enlarge it so that it is very clear to you. Where it is? Yeah. See, this R wave has been missed.
Yes. Why could that be the reason?
The program has got this inbuilt capacity that it calculates the average height of the R waves. And 1 or 2 standard deviations, if the variation is there, that it will include those R waves. But if it goes beyond that, it misses. Now, in settings, we can have a little bit of change. See, it is a preset thing. Now we will do is a custom thing, and we are able to change, go to advanced, and we will decrease the standard deviation to include that R wave. Say maybe if we do it to 2, because our R waves are reasonably big. Okay. And okay. See, it has picked it.
Oh.
Okay. But we will have to see that if we are decreasing the standard deviation down, there may be some other artifacts which the program starts picking, which is not good. Okay. So we will have to strike a balance. See. Now we go back to.
Isn't it more accurate to just ignore it if the program
No.
missed one beat?
No. Always try to get proper readings. If we are unable because of so much disturbance in ECG, then we will have to do something else. Otherwise, don't do that. Okay. Now you see, it's a whole clean record. Now if I just add that up and see, the difference become less. Because of short segment of only 48 beats, it became 36 and 15, and now back to 56 and 33. So this is a demonstration that you will have to make a comparison with comparable durations also. Okay? So the person who is going to sit to do the calculations should be clear in mind that I have to pick proper intervals and I have to make adjustments if required. Don't miss the things and don't overdo it. All those.
How can I decide that this is the perfect interval?
Perfect interval is 5 minutes in most of the cases. For example, the tilt, you have 5 minute baseline, 5 minute tilt, and 5 minute post baseline. Okay. For deep breathing, because it is a 1 minute total, 1 minute interval. So pre should be 1, post should be 1.
Okay. See,
okay. For comparison,
I will select 1 minute.
If when you are on deep breathing,
okay.
So select a 1 minute interval before deep breathing. Then during deep breathing, of course, it is total 1 minute, and then after deep breathing, again 1 minute. For Valsalva maneuver, this is not possible because that is only 15 seconds.
Yes.
Okay, so we will not be doing it for Valsalva. But for isometric hand grip, select 3 minutes before, because we will have the isometric hand grip for 3 minutes, and then 3 minutes afterwards. So relevant thing. The comparison should be apple to apple and peer to peer. Okay, we should not compare a 5 minute segment with a 1 minute segment. Yeah. All right. So this is how you are going to record for the whole. Now you could go to any segment by pressing onto the comment. So for example, now hand grip, if I just press, I am on the record of hand grip. I go to the comment section, okay, select, say, tilt up.
Okay.
So now I am on tilt up. So what I will have to do, I will have to select a 5 minute before the tilt. Okay,
Where does it show the time? It's 5 minutes.
time is from here. So this is 30 minutes, 31. So you should be at 26. And now there are a number of disturbances here. So let us see.
This is all during the rest before we start the tilt.
Yeah, but this has to be analyzed. Okay, so it has done those analysis, more or less. Okay, we go to settings and just see that this is ticked as exclude ectopic from analysis. So program automatically excludes everything.
So Doctor, I have a question. So for each participant, we'll go in, we'll take the base interval before the maneuver itself. For example, I'll take if we have 5 minutes before we start the deep breathing. Of course, we'll take 1 minute so we can compare 1 minute.
It's a 5 minute baseline. Okay, then you start deep breathing. When you are making calculations, because you are going to calculate 1 minute of deep breathing, so
We'll
just
take
select
1 minute.
the 1 minute before deep.
Yeah, exactly. That's what I meant.
Yeah.
So 1 minute of the base and
Yeah.
1 minute of the deep breathing.
Yeah, that is for comparison of base deep breathing.
Yes, exactly.
But otherwise, because you have to give another parameter that your baseline HRV was this. That should be 5 minutes one.
Yeah.
Okay. But when we are making a comparison of deep breathing with normal breathing, that should be
Depending on the time itself for the maneuver.
Yeah.
Okay. So for each, we'll go through all,
Yeah.
the baselines for the parameters we need and the maneuvers itself with the base.
Yeah.
Okay.
So now this is the beat classifier view, and there are not many which are, you can say, out of question things. So we include all of them and then see the report. So we have selected 390 beats and 736 average RR with a SDRR of around 70 now, RMSTD 49 and 15% RR 50. Good. We have got a reasonably good data.
Okay, but so Doctor, during analysis, we can, I think, for myself, I can get these numbers and I can calculate them. But I don't understand what this factor or the one below it is. I know what the standard deviation is, but these two I don't understand them. Do you think, do we need to understand them, or we can just get the data and collect it and that's enough for us?
I will, inshallah, make an Excel file for you to make you understand that how they are calculated, at least the time domain ones. Okay? The frequency domain, because it's a program that converts it, so I will just give you later on that what does it mean actually. Okay?
But we can like start with the participant and do all the work
Yes,
and
yes,
get
of
all the
course.
data,
Yes.
yeah, without understanding these for now, at least.
Yes, no problem
Yes,
with that.
yeah.
But important thing was that you understand that how important it is to get a proper ECG
Yeah.
before embarking upon others.
Yes. Yes.
Okay. So add to data pad and then go to actual tilt.
شباب معانا انتم فاهمين؟
Hey.
Okay. Now this is the actual tilt, and we go to 5 minutes end.
This is the post tilt.
No, this is the actual tilt.
Yeah. So during the stay, during
Yes.
After we
Up. Yeah. Okay. So analyze. Again, there are a lot of things which are. So can you tell me why now it is segregated there towards shorter RR intervals?
Because it's unsure if they should be included. The program is unsure if they should be included.
No.
With us.
That we can include, but why the shift is here?
Maybe the parasympathetic not
During-
dominating here.
Yes, of course. Simple thing. Huh? During the tilt, parasympathetic is less and sympathetic is more. So the heart rate is faster. So RR interval is shorter. So this is not abnormal. This is all normal. We will just include this. Okay.
And why did the program not include it?
Because
it is
we
short.
have made the setting. It is obeying us.
Because we chose the time.
Yes.
Okay.
Yes.
yeah.
Okay.
Right.
So now add to data pad and now see the differences, 1 or 2 differences, whatever it is. See, the RMSSD during tilt was 40, before tilt was 49. During tilt it is 26. So there is a very clear shift that during baseline your parasympathetic is more active and during tilt it is less active. Okay. Same is true for this SDRR. But it is not very apparent here. But nevertheless, there is some degree. Here it is 69 and during tilt it is 63. There is a difference. So I hope now you understand this thing.
Inshallah.
Now it is up to you to develop the file, the template file. And so I will just show you now. Save this file. Save as. We can save the file as lab chart data file or lab chart settings file. Okay. Now we will save it as a setting file.
What's the difference?
In settings file now, all the settings whatever we have done will be there, but data will not be there. Now you open this settings file and
Just a template.
A template. Yeah.
append the data file
Oh, okay.
to this one. So now you don't have to do the settings every time. So all the things are already there. You just add data, and the data is there. Clear? Now see, if I now open the file, I first close this one.
Doesn't have any data, only the settings.
Document. Yes. Do you want? Now open the lab chart again. Lab chart program. None found. Okay. We will open where it should have lab chart gallery probably. My data, my settings. Where was the file saved?
Desktop maybe.
Maybe desktop. No? This is
Yes.
no lab chart file. What was the file name? It will find out.
The
3.
3 Jan.
Yes. Up. You have to. 3 JA.
I don't think there's another file called this. So you can just
Not
Maybe
file.
check back in the documents after you selected the lab chart settings.
Yeah. Okay. But it should. Open. Yeah, this one. Downloads. It is in downloads.
It's because it was uppercase, so
Yes.
it didn't show it. Yeah.
So now it is the setting file. Now what I need to do is append. This one is the old one, huh? So we'll append this file.
Yeah.
And go to now data. Let us see. This is the other file. It has been opened with this setting. Now let us see. Is there a useful data somewhere? Yes, we have.
Yeah. We'll have the
Whatever. Now we can do the. This is pulse or what? Channel number 2, huh? Okay. selection. So it has, okay. This is a shortcut and not the right thing to do, but just to demonstrate that you open the setting file and append the new file and then name it properly so that you know which subject it belongs to and save and then add data. If we analyze now, something will come probably. The report is, there are not enough beats to analyze because all of them are red. So if I go to beat classifier and bring them to blue, then it will be okay. Yeah. Analyze, see the report. So this report you can add to the data. Okay. Sorry. So for today's, this was the main lesson, that how to set up your file, how to automate your data analysis, and what are the most important things to keep in mind. So now your job is to develop the template file and then analyze two files we have already, isn't it? One was
one complete file and the other with Isa. He didn't have a isometric handicap.
no problem.
Okay.
Whatever, because this is now the practice session. You will have so many questions. What to do there? So these should be cleared before you ask a subject to come, because there may be some small things which are apparently very small, but they may be having very big effects on your final data. Okay.
So next step, we analyze the information we got from the files.
First of all, develop the template with these 27 parameters, whatever it is. Then analyze so that all the values are there in the Excel file.
Yeah.
And then we go to the next step.
Okay, so we send it after we analyze all of it, and we send it to you so you can check it and see if we got something, there's an issue with it, or what do we do?
Yes, you analyze and then let me know. First, develop the template and send me the template. That is step one. In the meantime, analyze and then send me the file also. This should not take more than 2-3 hours. Template, maybe within 20 minutes you can make, isn't it?
Yes.
And the analysis also, the first time it might take half an hour or 1 hour. But then once you are, it will be 10-15 minutes job. All right?
Okay.
All right. We go to